is. It's on the page that says like and unlike terms in the font Blush Bear, which is the second page of the first booklet I gave you, which opened with the font with modeling polynomials in the font Curls, MT. All righty then. Okay. This term, once again, I remind you all that this first little bit is why things work. Okay? It is not how to do it. It is why it works. Then we get into how to do it. Okay? We will begin with why we are able to manipulate polynomials the way that we indeed manipulate polynomials. First thing you need to be aware of is this term, zero pair. What does zero mean?
Nothing.
Nothing. Absolutely correct. It means nothing. What does a pair mean? Two. So a zero pair must be two things that give us nothing. Yes?
Yes.
So, that's not a pair. Zero is the same thing. But you're on the right track. 1 and minus 1. What does that get you? 0. Excellent. 3x and negative 3x. What does that get you? No. I have 3 x's, and then I have negative 3 x's. What would that get me? 0. Excellent. So all of you understand it with symbols. Great. What it actually means is this. There's 1. There's negative 1. What do you end up with? 0. Because the negative cancels the positive. 1, 2, 3 positives. 1, 2, 3 negatives. What do you end up with? 0. Oakley dokley? That's what a zero pair means. It is... Yes? Did I watch what? Crap, that was on last night. I would have thought it would have been next week. Damn, I do still like Tree Houses of Horror. How about the last Simpsons I go out of my way to watch? A zero pair is a pair of opposite polynomials. Now, the example I've given here, they are monomials, yes? Yeah. But they can indeed be polynomials as well, which we will get to as we get further into this. But as always, I start with the bare bones. So, we are going to simplify this tile model. That means what we are going to do is we are going to remove zero pairs. So, let's look. First of all, what do I have all 3 kinds there? Yes. So, remember, the gray ones are the positives, because heaven forbid we sound racist. So, do I have any other positive big guys? No, so there's no canceling to be done. So I keep the one big guy. Do I have any negative bars? I have 1, so I'm going to cancel that one and cancel that one, leaving me with 1 bar. Do I have any little guys?
Yes.
Cancel, cancel, leaving me with 2 little guys. This is what we call a pictorial representation. All right. This leads us in math class to, what do we call the big guy? Any letter squared, right? I'm going to choose a crazy letter. I heard someone say Q. I'm going with Q. Q squared plus Q minus 2. Is everybody Gouda?
Great.
All right. Could this be a fish?
Yes.
Could it be a lightning bolt?
Yes.
Could it be a dollar sign?
Yes.
Yes. Excellent. If this is a lightning bolt, what must this be?
A lightning bolt.
Also a lightning bolt. We cannot change our variables in the middle of a question. But we choose the variable. Does everybody understand?
Yes.
Excellent. It is a safe place. All right, so you guys should have no problem doing that. Cancel, remaining tiles, write me a polynomial. It should take you about 10 seconds. Go. 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Stop! How many people are done? Not bad. Carry on. Everybody finish. Josiah, did you get that apple from a scout at a grocery store yesterday? Oh, that's something I did this weekend. I handed out apples with my son because he's a scout.
I did that. No, you didn't. Not this weekend. I mean, I've done that before.
He's too old to be a scout now. Scout ends at 12. If he was still in scouting, he would be a venturer. But I bet he's not in it anymore. See? That doesn't surprise me.
You're in what?
I was never in Beavers, but I always wanted the cool hat.
I want the beaver hat too as well. But only because it has that cool ass tail on it. I already have like 20 bucket hats, but none of them have that cool ass little beaver tail on the end of it.
I want one of those just for that.
Yep, me too. So, of course you have canceled, 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 canceled. And you have 2 bars and 1 little guy. And then you write the polynomial. Who chooses the letter?
We do.
You do. 2 H minus 1. How many people chose H? Nice. How many people chose N? How many lamos just chose X like you always do?
Not me. Not me. I chose Q. I chose Q.
All right. This one. Cancel. 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 Leaving you with 2 big guys. Shaded. 3 bars. Unshaded. 2 little guys. Unshaded. And your polynomial looked like this. Negative 2j squared plus 3x plus 2. Is that okay?
Yes.
No, it's not.
No, why not? Carlin,
Oh, because that's X and J.
I used 2 different variables. I know you didn't see it, Leighton. That's why you said it was okay. If you had seen it, you would have said, Mr. Myers, you're a doofus. That's not okay at all.
I would have.
What?
Why does it have to be the same?
Because if you use different letters, then you have 2 different values, right? So, for example, X might equal something, and J would equal something else, which means you cannot use the algebra tiles. Nor can you combine it together, which we will get into next lesson. Mr. Anderson.
What's your favorite animal?
Elephant.
Me too.
Because they bury their dead and take their children to play in their bones.
Whoa. That's almost something that you would do.
Well, I used J.
Yes, Sam?
I use L.
Awesome,
I
possum.
did a giraffe.
Okay. Everybody can do this, yes?
Yeah.
It's unbelievably easy, and yet people have trouble with it.
Yeah.
Oh, wait. No, I don't want to say that yet. Terms that can be represented by matching tiles,
Polynomials.
no,
Like
Polynomials.
are called like terms. Now, please, 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 please understand both the concept and the method. Okay?
yes.
Concept is this: matching tiles. What would be the tile for x squared?
X squared.
The box.
The big box. Now, any other big box tile will work. So if I went 2 of these, could I put them together?
Yes.
Yes, that is the concept. How does it work in math? What do I write here? 2x squared. Why must it be the same letter?
Because my different values.
You cannot have different variables because we are only counting x's here. Everybody got it?
Yeah.
So what would this be? I'd have 4 unshaded bars. And what could I put here?
17 unshaded bars.
17. I could put shaded bars
Whoa.
because they are the same
Fairness.
tile.
So it doesn't matter what.
Doesn't matter if it's colored or not. It's the same tile. So this would be negative 17s. 6, we'll talk about it in a sec, Carl. You'll see it in a sec, trust me. 6, I'll change colors. 6 little guys.
7.
And you could have 7 little guys, which would be what?
13.
6 and 7. No variables. And then just to remind you, you could also have 5 bars unshaded and 5 unshaded, which would be 5W and 5W. Now, that is concept. This is usage. What do you notice about all of the ones that have a variable? They all have to have the same what? Same variable and same degree. Absolutely right. 2, 2. 1, 1. 0, 0. 1, 1. So these are all unlike terms. Right? They are all unlike terms because of what? What makes these unlike? Carla. Yeah, these are unlike because the degree is different. This guy's 1, this guy's 2. What makes these guys unlike?
One has variable, one doesn't.
One's a variable and one's a constant. What makes these guys unlike?
One variable, one variable.
Degree and variable. Okay? Everybody Gouda?
Great.
Okay. So, simplifying polynomials is done by combining like terms. Okay? Now, what we just did, 0 pairs, is an example of simplifying pictorially. Now, if I actually gave you little algebra tiles to play with, then we would say we were simplifying concretely. And we will be playing with algebra tiles soon, but not today. So, this is pictorially. Now, notice there's a new word in example 2.
Symbol.
Symbolically. What is the symbol? The symbol for what I'm illustrating right now.
Mouth.
One plus one.
Up.
1 plus 1.
Which would be
2.
2. The symbol is 2. 2 is a symbol. Because this symbol, the number 2, represents 2 things. What 2 things? Any 2 things, right? That one symbol means whatever you are talking about, there are 2 of them. Got it?
Yeah.
Everybody understand?
Yeah.
Okay. Everyone says, well, isn't 2 just 2? No. 2 is what we use to represent the actuality of 2 separate things in front of you. Got it?
Yeah.
Okay. So, if 2 is the symbol, simplifying something symbolically must mean we are going to do what with pictures? What, are we going to use pictures at all? No, we are only going to use the symbols. So to do that, we have to know all the definitions of which we have already spoken. So I got to look here. Simplify means we are going to combine our like terms. Now, guys, I cannot stress this enough. This concept of combining like terms being simplified is kind of like breathing in math.
You need to know it.
You need to know to do it automatically. You don't wake up in the morning and go, oh yeah, I gotta breathe. You don't do that. You don't sit there and go, oh yeah, heartbeat. It's automatic. That's how much or how far you have to get along with this concept of combining your like terms. You will do this so many times between now and the end of your math career. Even if that math career goes to a doctorate level of mathematics. Combining like terms, you will continue to be doing so even as you work on your PhD in math, if you choose to go that far. Does everybody understand me?
Yes.
And like all math concepts, it starts bone-numbingly easy. And it never gets more difficult unless you don't pay attention now. Okay? All right. So I'm going to look at this. And since I am working symbolically, I am only going to look at the symbols. And I am going to use colors to help me. The first kind of symbol I see is an A with a degree of 1, yes?
Yes.
Which means if there are any other A's with a degree of 1, they can be combined. Are there?
Yes.
Yes. Now here's where it gets complex, but it isn't really. That symbol right there means 2 things. What does it mean? Addition and positive. This lack of symbol in front of here means what? Positive. So these both mean positive. If I were going to draw this, and I'm just going to draw the shorthand way, I would draw 3 A's, correct?
Yes.
And then I would draw 1 more A for a total of how many?
4.
4 bars, yes? But we don't want to waste our time with bars anymore because we're smart kids. So all we're going to do is add 3 plus 1 to get 4 A's.
Yes.
Got it?
Yes.
Easy peasy lemon squeezy. And then I find plus 6 and minus 4. What does that give me? If I were going to draw it, I would have 6 little guys and 4 shaded in guys, yeah?
Yes.
4 of these would cancel 4 of those, leaving me with what left over?
2 positive.
2 positives. 6 minus 4 is positive 2. Does everybody see how to do it?
Yes.
Do you need to draw anymore?
No.
No. Go ahead and use the numbers. But be warned, you have to account for every number. So go slowly, especially now with the easy ones. If you go slow with the easy ones until you have it ba-boom, then the more difficult ones won't be a problem. I will wait a second whilst you try to do this one. I'm going to give you another thing that might help. A lot of kids like to learn from seeing. If you're not carrying highlighters, this is hard to do. But a lot of kids will do this. Oh, I see a squared. I'm going to put a box around the squares. Then I'm going to put a box around every other squared I see. Okay, I'm done. And I would go negative x squared plus 3x squared is negative 1 plus 3, which is what?
Positive.
2x squared. Got it?
Yes.
Then they would get rid of that. Then they would look for the next thing they saw. Oh, and they may use a different shape, a diamond around any x's. Oh, there's another one. 4x minus 4x. 4 minus 4 is 0. Would I write it?
No.
No. Then I go to the next one. Maybe I circle it. Negative 5 plus 1. Negative 5 plus 1 is negative 4. Does everybody see how to do it?
Yes.
I don't care what you do. I will tell you right now that when I collect like terms, I do no drawings, I do no highlighting. I just do the work in my head. Okay? So you guys try 1A and B. And when you are ready to give an answer, somebody can go ahead and give that answer after they put up their hand and wait politely for me to call on them. Leighton?
X squared plus 5x minus 3.
Is that correct?
Yes.
Abso-smurfly right. Ms. Horner? Excellent. Hit me. 13x minus 4. Is she correct?
Yes.
Abso-smurfly. Why? Because she saw 2 minus 2 disappear. Then she went plus 6 plus 7, 13. Dealt with. 7 minus 11, negative 4. And that's it. Now, guys, I'm not joking. That's it. But like I say, you need to be able to look at a mess like this and go ba-boom, ba-boom, ba-boom. Got it?
Yes.
That's where I need you to be. And we've got to do, if you look on your outline, up to here is going to be that easy. But that's because from here down, if you can't do this as easy as breathing, this is going to be a pain. It is going to be painful to do. Do you understand me? So we are going to go extraordinarily slowly, just like we did the last unit. So slow that you are going to feel like I am treating you like babies. That is not so. This is where grade 9 usually ends. And it usually takes forever to get to there. Notice that you guys are doing basically another entire unit. So this has to be boom. This has to be where I want your times tables to be. Right? 9 times 7. That fast. Okay? 8 times 12.
It's 966.
That's what I need for multiplying or for all polynomial operations. Okay? So that's why we are going in very small, very manageable chunks. Carlin. The first quiz is going to have everything up to there. So drawing, combining both picture and symbolically, and then adding and subtracting, which we haven't done. We'll do that tomorrow, which will be, again, picture and symbol. Okay?
Yeah.
Gouda? Great. Now, it's 12:41. You've got till 1:05. I think 25 minutes to add some numbers together should be enough time, right? I don't need you to have homework, usually in these units, until we get to the end, right? All the way down here, you're probably going to have homework. Up until there, you should be able to figure that out and get it done in class. Okay? Okay. You go, grade 9s. You go. Oh, one moment. I'm the worst kind of math teacher. No, I recorded. I forgot to ask because I know nobody had any trouble with it. Did anybody not get the answers the same as the back of the book? Okay. Now, one thing I would like to do, I'm noticing that nobody ever has a question on what I assign. So I'm going to start adding. You know how your textbook goes in chunks? Like there's the discuss the ideas and then practice, check, apply, assessment, focus, and then it goes to take it further.
Yeah.
Okay? I'm going to go and say, if you are extraordinarily comfortable with this, then I would always suggest the take it furthers. Now, some of you won't do it. Some of you are busy. Some of you don't do homework. Whatever. I don't care. But if you really want success, not just in the 9th grade, because going up to 21 will get you that A in grade 9. But if you want an A in grade 10, grade 11, grade 12, then I'd really recommend doing all the take it furthers. Sometimes I will assign one of them like I did today, but not always. I would recommend doing all of the take it furthers. You don't necessarily need to. They won't show up on many tests, but it's a really good idea. It's kind of like trying to bench press 10 extra pounds when you're at the gym. You know you can press 150, you try to press 160. Okay? Why? Because it makes you better. You know you can run a 5-minute kilometer, you try to get it to 4. Gouda? Great!